My name is Rahul Singh Thakur, and I am working as the lead software engineer in Salesforce. I wanted to talk about this. How can we scale the service, right? So I do want to talk about the how can we enhance the cloud scalability and the fault tolerance using the sharding. So before I start, I will give the little background about this. So nowadays, it's very common practice to deploy the service as microservices, right? When we deploy the service as microservices, there are generally more than one replica of the service which runs. And it is mainly done because we want to make sure if there is an issue with one replica of the service, the other still continue to serve the traffic. So my idea is also on the same, but it extend the idea. So instead of having just one instance of the service, we can actually shard the services itself. We can have the multiple instance of the services, and then each instance of the service serves the some traffic, right? And using this architecture, we can actually improve on fault tolerance and actually have the high availability for our service. Yeah. So I will go in deep down on the different aspect of it. So first thing is that why sharding matters, right? So if we do not shard, right, then you have one single point of failure, right? Everything goes on to the same place, right? Which means that if there is anything has to go wrong, it will impact all the incoming traffic, right? And since everything is coming onto the single place, you cannot have an intelligent load distribution, right? And then it affects your availability, right? If everything is on one place, everything has to go down, it will reduce the availability of the service. In my proposed architecture, so I'm introducing a metadata service. And so in my proposed architecture, there are different instances of the service, right? So not only one instance, but different instances of the service. And now since there are different instances of the service, the requests need to go to the one instance and always need to go to the same instance. So because of that, we need a metadata service. The responsibility of the metadata service is to make sure that for a given request, identified as the same request using the IP address or the customer credentials, it always goes onto the same shard of the service, right? So that's why we need the metadata service. So metadata service also can be used for managing more metadata about the all the services that participate in this, and then it knows about the all the shards of the services. And then at the end, it will redirect the service to particular instance. Okay. So before I go further deep, I just want to focus one more time, like what are the benefits of it. So since we have now multiple instances of the service running, it will improve the availability of the service. If one instance is down, still there are, let's say we have 5 instances of the service, still there are 4 instances running. So that means the availability is down only by the 20%, right? And it also helps to make sure that all the requests goes to the same service instance always, which can help you. So for example, we have 5 different instances and then each serve the fraction like 20% of the customers. And then if we have a local cache, then it can serve the customer better, right? So we have a small instance and then we know the request from the customer will always come on this particular instance. So then it will be able to serve from the cache, right? And third one is like it can optimize the deployment, right? So now if you can configure your pipeline to do the staggered deployment, and whenever you are releasing the change, not release on all the pipe instance, but release it on the first one instance first, and then do all kind of the validation to make sure okay to go into production, and then it's not causing any regression. Just want to add more on the benefits. Since we have multiple instances of the service, we can actually have the intelligent routing. Okay. And then if you want to scale up or scale down one particular instance of the service to serve a different purpose, then you can actually scale it up. And then while you keep the keep the, so for example, let's say you have 5 instances of the service and then one instance which serves the current, the request for the, let's say for the current day. Okay. And then the other 4 instance, they serve the request from the historic data, right? So you can actually scale the current service which serve the current day data to be more performant. So yeah, this is just an example, but the idea is that if you have different instances, then you can actually manage them separately, and then you can have the intelligent load distribution also done. Fault isolation. For example, let's say we have, again, going with the same example, we have 5 instances, they are running in different 5 availability zone. Let's say there is an issue with the 1 availability zone. It does not impact the other 4 instances which are on the different availability zone, right? So you can actually isolate the fault. You can minimize the blast radius. Um, and then also, if we use it correctly, we can actually use it for the cost efficiency also. Because if we had only one instance where you have to keep it scale up that instance all the time, in this scenario, you can actually scale up or scale down the different instance at the different point of the time. So it gives you the flexibility of managing it better. Okay. Now I do want to talk about a little about the implementation. So we need to dynamically provision this instance, right? So now since we have more than one instance, and it is possible for the number of instances to grow or reduce in the size as and when the product grow or shrink, right? So it is possible. It is very important for us to have a service which can provision the service instance dynamically, right? So it need to be configurable, and then it need to be and then there need to be the configuration which can be done separately for the each instance, right? And yep. So going next. Yeah, we also need to have maintain some kind of configuration for all this instance, right? Since these are the different instance, I mean, it's the same service, but it's still different instance. There may be some runtime properties which are different for the different instance. And what we want to make sure is that they are configurable, right? So for that, we need a configuration service. And for each instance, we configure the properties same or differently depend on the use case, and then used when we deploy the service instance. Okay. So as I told before, like we also need a metadata service. The responsibility of the metadata service is to make sure that we are able to route the request to the same shard every time, which means that we need to have the consistent routing. Also, I just want to touch upon the stateful migration. So if your service is stateful, which means that it persists some kind of the data, then if you want to move the customer from the one if you want to move the customer from the one instance to another instance for any reason, right? There can be multiple reasons. For example, one of the instance is not able to serve any more traffic, so you want to distribute the traffic and move some of the traffic to the other instance, right? Or maybe for some other reasoning. For example, you have a logical distribution of the customers, but then for some reason you decide to move the one customer from the one shard to another shard, right? So this is like open to but the point is, for any reason at any point, if you decide to change the shard for a customer, and if it's an stateful service, then we have to take care of the stateful for the data migration also. And we all know data migration is not easy. But I think if it's done correctly, we can actually have this also. The point is that we have to consider the stateful migration when we are adopting to. Okay. Now I would like to talk about some of the challenges. One is the debug complexity, right? When we want to debug an issue, right? The first thing we need to know the routing of the shard happen correctly. Then we need to know which shard the customer belongs to. And then for each shard, since there are different configuration, we just want to make sure that so it's up to the complexity for debugging, right? Migration complexity. I think this is one of the biggest challenge, the migration complexity, because when, as I explained before, we have different instance. If for any reason we decide to change the customer from the one shard to another shard, we have to moving the data in the live production system is not easy. That's why I recommend, if we ever try to do it, consider the dual ingestion. So you keep ingesting the data into the old shard, you keep start to ingest the data into the new shard. When the data is in sync, then you move the customer from the old shard to new shard. And then once the customer being served from the new shard, then you can think about cleanup from the old shard. And also, I will suggest that if we keep the retention based cleanup, that will be a nice. In that sense, you don't have to worry about cleanup of the data, but like when the data reach to the end of life, it's automatic. Then third is infrastructure complexity. So since now we have multiple instances, you need to have a service which can spin up the new instance and take care of it, right? Yeah. So this will add up the extra complexity. The data consistency, I think that the data consistency is mainly when we actually moving the customer from the one shard to another. So we just want to make sure that the data is consistent. Network latency is also in the same sense that when we are actually moving the customer from one shard to another, we are actually doing the dual write, and then that might add up to the latency for the customer. I do want to support some of the mitigation for the above problem. The first thing is that if we have the robust monitoring, so for any given customer, if we know the like which shard the customer goes, and then all the configurations that we can see given shard, it will, and then having a proper dashboard and alarms to monitor the each service instance, right? This will help to reduce the debugging effort to and can be done very fast. Second is caching strategy. The caching strategy will help a lot during the in the metadata service when we actually want to assign, when we want to decide the which shard the customer should go. I think the caching strategy will play an important role, because the adding or removing the shard is not a frequent operation, right? So we can very well have a cache which gets invalidated whenever there is a new and right through cache in here, and then this will help us. So this will help us like doing the routing without adding up on the much latency, because we'll be doing it from the cache. The dual write system. So the dual write system is very important when we want to do the we want to move the customer from the one shard to the another. I think if we make sure that the customer do not see any downtime during this process, and then the customer even won't know if there was any change on the back in the back end. Yep. Yeah. So I just want to conclude on this. The idea is to have the multiple shards of the service, and so that each shard serve some of the data or some of the customer. It helps you increase the availability of the service, also doing the better load management, and improve on the fault tolerance. Yes. So I think, yeah, that's it. And thank you very much.